Hello. Today I'm going to go over Creation of Matter lecture. So we're talking about the Big Bang and the formation of our universe as best we understand it by the evidence presented so far. So what I have here, there's a graph and it shows the elapsed time of the Big Bang in seconds. So this is 10 to the negative 43 seconds after the Big Bang. So just fractions of a second after the Big Bang, and then the temperature. And you can see the temperature was extremely high, 10 to the 31. That's 1 with 31 zeros after it. And the temperature was so high during this time, during this first partial second of the universe, that matter couldn't exist. Temperatures were too high for there to be protons, neutrons, electrons. So the early universe was so hot, no matter existed. As the universe rapidly expanded, it cooled. So in that instant, the universe is expanding. Space and time are expanding. As it does that, the energy can spread out, meaning the temperature drops. All right. Down here, we see formation of the subatomic particles that we're used to. So when it cooled enough, energy could transform into matter. So eventually we have gamma rays that will form protons and neutrons. Protons and neutrons could form, but only at very high temperatures. So the temperature goes down to a certain point, still extremely hot, but now those subatomic particles can start to take shape. That energy converts to matter of protons and neutrons. Once we lose more energy, though, this no longer happens. The protons and neutrons can't be created any longer. So temperature goes down to a certain point, and we have our most of our matter. Later, electrons would form. So they would come, you could see the electrons forming after the protons and neutrons. But again, as the universe cools, no more formation of these particles. Okay. Arno Penzias and Robert Wilson built a microwave antenna and quickly discovered the cosmic microwave background. This is the first light that was able to travel freely. So eventually, once the universe expanded and it cooled down enough, light was able to actually leave a particle, a photon, and not get immediately absorbed by something else. Once that happens, that's the first light that we're able to detect, or the oldest light that we're able to detect of our universe. That's what the cosmic microwave background is. And it's a map of the universe that looks like this. We've got a couple of different satellites that have been used to map this. And we just get more and more detail, basically, more and more resolution. And what you're seeing are slight differences in temperature in the background of space, of the universe. Again, this is showing the earliest light that we can see of the universe after the Big Bang. The blue and red are the map. Oh, the blue and red on the map are slight differences in temperature. This difference also corresponds to density differences and the structure of matter in the universe. So this also gives us an idea of how and why matter collected into certain regions, why some areas pulled together to form galaxies, where other areas were just empty space. All right, I hope this helps, and let me know if you have any questions.